Hello, it's Mr. Obi from GCSE Physics Explained. This video is Electromagnetism Part 2. Learning objectives. Know what a solenoid is. Know how to draw the magnetic field pattern for a solenoid. Know how a solenoid can increase the magnetic effect of a current. This is a recap from my Electromagnetism Part 1 video, where we looked at the right-hand grip rule for a straight wire. If you haven't saw that video, check it out first by clicking the link at the top of the screen now. So this is with a small current. Watch how fast the compasses move. If I turn the current up higher, you can see that the compasses move pretty fast. So the more current you're using, the stronger the magnetic field you've got. Now, instead of just having a straight wire, it was discovered that if you take the wire and you coil it, that makes the magnetic field stronger, because instead of the magnetic field being stretched right out, the magnetic field is now being concentrated in a smaller area. So this is one coil. Let's have a look and see how strong the magnetic field is. Not very fast. So the magnetic field is not very strong. If I use 1, 2, 3, 4 coils, let's see how strong the magnetic field is now. So how fast the compasses move, that'll determine how strong the magnetic field is. Right, now they seem to move a lot quicker. See how jerky they are. And also, if I was to turn the current down, so this is a small current, you can see them, the compasses don't move very fast. And then if I turn the current up, more electrical current should cause more magnetism. If there's more magnetism, the compasses should move quicker. Yeah, they do, look at that. Twitching all over the place. The more current you've got, the stronger the magnetic field around the wire. Now, if you take a wire and you turn it into a coil, that's what we call a solenoid. Now, a solenoid has got a magnetic field which is the same shape as a bar magnet. One end of the coil will act like a north pole and the other end will act like a south pole. Now, we can use the right-hand grip rule once again to work out what's happening here in terms of the current and the magnetism. However, the right-hand grip rule for a solenoid is different to the right-hand grip rule for a straight wire. This time, the fingers represent the current, not the field, and the thumb represents the magnetic field. Okay, not the current. Now, how do you work out which way the current's going? Well, remember, we're talking about conventional current. So we're going from the positive side of the battery. The current's going to come through this cable. Now look closely. The current comes along this way. Now the current is looping over the top and it's going down the bottom, and then it's coming over the top again and down the bottom. So the current, if my fingers represent the current, you can see the current is going over the top and then coming back under the bottom. So if I put my hand, my right hand, like that, that's basically showing me which way the current is flowing. Now your thumb will show you which way the magnetic field is going. Now at the moment, I haven't got it switched on. So you can see these compasses are all lined up with the Earth's magnetic field. They're all pointing this way. Now when I turn this solenoid on, if my right hand grip rule for the solenoid is correct, all those compasses should start pointing that way, where my thumb's pointing. Because remember, the fingers represent which way the electric current's flowing, and the thumb represents which way the magnetic field's going. Now that is the right-hand grip rule for the solenoid, not the right-hand grip rule for a straight wire. Okay, so I'm just about to turn the current on. Here we go. 3, 2, 1. And there we go. See, the magnetic field's going in here. It's coming along that way. It's coming out. It's looping round here. And it's coming down that way. Remember, the magnetic field travels out of the north, goes down into the south. And just like a bar magnet, you end up having this shape of the magnetic field. So we just follow which way those compasses are pointing, and that shows us the direction of the magnetic field. Now we can also use the compasses, I guess, for showing us the shape of the magnetic field. Now, just like a bar magnet, the further away that these compasses get, the slower they move. If you keep the compasses very close, then they move very fast. The way that the direction changes moves very fast. Now in an exam you'll have to know where the strength of the magnetic field is the strongest. Watch how quickly these compasses in the middle move compared to the compasses on the outside. 3, 2, 1. If I was to reverse the current, watch this. If I put the current in at the top now, so the current is now coming in at the top and it's coming out at the bottom. So if we look closely, you can see the current's coming in here and it loops up over the top. So the current, remember your fingers show you the current, so the current's coming over the top. Current's going over the top and it's coming under the bottom like that. It's going round. So my thumb's pointing this way, so that's the way the magnetic field's going to be pointing. So watch, if the magnetic field's pointing this way, going through the middle of the solenoid, that means it's going to come out and it's going to go round the back here and round the back here and go into that side there. So these two compasses should turn around. I've got a different coloured pen. So if I've reversed the current, I've reversed the field, so this time the field's going in, it's coming out there, so you can see it's opposite to what we had before, which was represented by the black. The magnetic field's coming out and round this way, and round here like that, and it's going into the top. And as it's coming out of this side, coming out there, coming round the side, pointing that way, it's going in there. Okay, so the fingers represent the current and the thumb represents the magnetic field. And remember, the magnetic field always comes out of the north and goes into the south. So this time, this end is the north end of the solenoid and this is the south end of the solenoid. Now a lot of people don't like electromagnetism, and I can see why. Can get a little bit tricky. Make sure that when you're using the right hand grip rule that you remember. One of the right hand grip rules for a straight wire, the fingers show you the field and the thumb shows you the current. Whereas for a solenoid it's the other way around. The thumb doesn't show you the current, the thumb shows you the magnetic field. And it's the fingers that show you the current. Okay? Alright, bye for now. Want to see more videos like this? Subscribe to my channel, GCSE Physics Explained. Thanks very much, and bye for now.